Imagine you are standing in the middle of the Lut Desert, 2,000 years ago. The sun is a relentless hammer, and the air is a furnace at 50 degrees Celsius. In this world, water should be boiling, and survival is a minute-by-minute struggle. But then you are handed a bowl of rosewater sorbet, filled with crystalline, crushed ice. In a world without electricity, without compressors, and without chemical refrigerants, how is this possible? Most historians will tell you it was magic or simple luck. They are wrong. What you are looking at is the pinnacle of ancient high-tech engineering. A structure so advanced, it defies the very laws of thermodynamics as we understand them today. This is the story of the Yakhchal, the ancient Middle Eastern superfridge that mastered the stars to freeze the desert. For centuries, the ability to harvest and store ice was considered the ultimate sign of a civilization's power. In Europe, kings paid fortunes to have ice hauled from mountain peaks, only for it to melt before it reached the palace. But in the heart of the Persian Empire and the Arab world, ice wasn't just for kings, it was a public utility. Today, we are going to deconstruct the impossible. We will dive into 3 specific, evidence-based secrets that the history books usually ignore. First, we will reveal the radiative cooling secret, how ancient engineers turned the night sky into a vacuum to suck heat out of water. Second, we will analyze Sarooj, a forgotten chemical compound stronger than modern concrete that acted as a thermal fortress. And finally, we'll uncover the Ice Master's economic blueprint, a social system that provided refrigeration to the poor 500 years before the West even understood the concept. If you think you know ancient history, wait until you see the physics behind the ice. Chapter 1. The Physics of the Night Sky, Radiative Cooling. To understand the Yakhchal, you have to stop looking at the ground and start looking at the stars. Most people assume these giant mud brick cones were just fancy basements that stayed cool because of shade. That is a fundamental misunderstanding of the science. The real secret lies in a phenomenon called radiative cooling. Ancient engineers in the Middle East understood a secret of the universe. The atmosphere has a window. If you can shield a liquid from the sun and point it directly at a clear night sky, that liquid will shed its heat in the form of long-wave radiation, sending that energy straight into the freezing void of space. Even if the air around you is 10 degrees Celsius, well above the freezing point, the water can actually drop below zero. But how did they achieve this in the desert? They built shadow walls. These weren't just walls, they were massive precision instruments, often stretching 15 meters high and hundreds of meters long, aligned perfectly on an east-west axis. During the winter months, these walls ensured that shallow pools of water remained in total, absolute darkness. By blocking every single photon of solar radiation, they allowed the water to communicate only with the coldness of the vacuum above. The precision of the height-to-width ratio of these pools was critical. If the wall was an inch too short, the winter sun would touch the water, and the process would fail. By managing the thermal exchange between the Earth and the stratosphere, they were essentially mining the coldness of space. They would harvest the thin layers of ice each night, stacking them in the central dome. But simply making ice wasn't the hard part. The real challenge was keeping it solid in a place where the ground itself could cook an egg. This required a material that shouldn't have existed 2,000 years ago. Chapter 2. The Sarooj Fortress, the Chemical Evidence. If you look at a Yakhchal today, it looks like a simple clay dome. But beneath that brown exterior lies a masterpiece of chemical engineering known as Sarooj. While the rest of the world was using basic mud and straw, the scientists of the Middle East were compounding a high-performance thermal insulator that rivals modern polystyrene. The composition of Sarooj was a closely guarded secret. It wasn't just dirt. It was a precise molecular mixture of clay, sand, lime, and ash. But the X factors were the organic additives, egg whites and goat hair. To a modern observer, this sounds like folklore. To a material scientist, this is brilliant. Modern analysis reveals that the goat hair acted as a fibrous reinforcement, the exact same principle we use in carbon fiber or rebar-reinforced concrete today. It gave the dome immense tensile strength, preventing the microscopic cracks that would allow cool air to escape. The egg whites and lime created a protein-based carbonation process, making the structure completely waterproof and airtight. This created what we call thermal mass. The walls of a Yakhchal were often 2 meters thick at the base. This thickness, combined with the insulating properties of the Sarooj, created a time lag in heat transfer. It would take months for the summer heat to penetrate the wall. By the time the outside heat reached the interior, it was already winter again. Furthermore, Sarooj was heat-resistant and reflected the sun's infrared rays. This allowed the Yakhchal to act as a thermal vacuum, holding thousands of tons of ice in a state of suspended animation. Imagine a giant thermos buried in the sand, capable of maintaining 0 degrees, while the outside world sat at 45. Chapter 3. The Bernoulli Lung, the aerodynamic proof. The most striking feature of the Yakhchal is the hole at the top of its cone and the strange towers surrounding it. These are the components of a 1,000-year-old forced air refrigerator. This system functioned through the integration of badgers, or wind catchers, and the Bernoulli principle. The wind catcher towers were designed to catch even the slightest breeze high above the ground. This air was funneled down through narrow internal shafts. As the air was compressed into these shafts, its velocity increased and its pressure dropped. This is the Bernoulli principle in action. This air was often directed over a qanat, an underground canal of cold mountain water. The air would lose its heat to the water, becoming incredibly cold and dense. This cold air would then enter the base of the Yakhchal, settling over the ice. Because cold air is heavier, it stayed at the bottom, hugging the ice. But as that air eventually picked up tiny amounts of heat, it became lighter. Instead of swirling around and melting the ice, it was sucked upward and exhausted through the hole at the very top of the dome. This created a constant, silent, and automatic cycle of cooling. The Yakhchal was breathing. It was pulling in desert heat, stripping it of its energy and exhaling the waste. Historical manuscripts from the Safavid and Abbasid eras reveal the existence of the Mir Ab, or the Ice Master. This was a high-ranking official whose sole job was to manage the ice harvest. In cities like Kerman, the Yakhchals were so efficient that ice was sold for a pittance, or even given away for free to the poor during the height of summer. While the kings of Europe were sweating in their palaces, the common street vendors of the Middle East were serving chilled fruit drinks. This was a level of social infrastructure that the Western world wouldn't achieve for centuries. The climax ultimate reveal. The ultimate revelation is this. The Yakhchal is not an ancient technology. It is a future technology. Today, as we struggle with global warming and the massive energy costs of modern air conditioning, NASA and global sustainability architects are returning to the deserts of the Middle East. They are studying the Yakhchal to design habitats for Mars and zero-energy cities on Earth. The secret isn't that they found a way to make ice. It's that they found a way to live in harmony with the most brutal environments on Earth using nothing but the physics of the stars and the wind. We didn't improve on their cooling, we just replaced their genius with a power cord. The Yakhchal proves that the history of the Middle East was a time of radiant cooling, chemical mastery, and aerodynamic brilliance. Our history is filled with these lost tech secrets that are only now being validated by modern science.